20 fast food restaurant hourly employees were surveyed to see how many hours they worked per week on average. The following data was obtained. And then we have the data. Assuming the population standard deviation, sigma equals 8, construct an 85% confidence interval for the mean number of hours per week that the population of fast food restaurant employees work. So this problem kind of walks us through the steps we will need to calculate this confidence interval. We're going to start by finding x bar, which is the sample mean. To do that, I'm going to use my notebook, and I'm going to grab the data. So I'm just going to copy and paste it over. So I'm going to store it in variable x. Okay, so that gets me the data. So I'll run that. Okay, now I have the data in the system. And let's find the mean. Okay, so to find the mean, I'm going to want the length of that data, which should be 20, right? Because we know the problem told us that there are 20 fast food restaurant employees that were surveyed. Oops. Okay, so I've got my n, and so my mean x bar, my sample mean, is just going to be the sum of all those data values that I have. So I'm just going to add them up by calling sum, the function sum, and then putting in x. And then I'm going to divide by how many there are, which I've stored in variable n. Okay, and whoops, and I'm just going to type x bar, and that way I'll be able to see my result. Okay, so according to this, the average value that I have from this data is 34.25. So of the 20 fast food, whoops, forgot the 5. Of the 20 fast food restaurant employees that were surveyed, they on average work 34.25 hours per week. Okay. Next, we want alpha over 2. So to find that, let's go here. We are told that we want to construct an 85% confidence interval. So that's our confidence level. Confidence level is 85%. Okay, that means graphically, we want to find the middle 85% so that we are 85% confident that the true population mean is somewhere in that interval. Okay, we are looking for this value and this value, the bounds of that interval. Okay, but to find that, we're actually going to need to calculate the amount that's left in each tail if we have 85% in the middle, right? So we know that there's 100% total, so that's 1. And if I subtract the 85% in the middle, that's going to give me alpha, the amount that's left. Okay, so let's stick, once we find that, we're going to divide that by 2, and that's going to give me this value here. Okay, so let's stick that in our notebook. So alpha is 1 minus my confidence level, which for this problem is 0.85. Okay, and once I have that, I actually want to know what alpha over 2 is, because that's what the problem's asking for, 0.075. Okay, so that 0.075 represents the amount left in each tail. So I know there's 0.075 in this tail and 0.075 in this tail. That's why we're dividing by 2, because whatever's left over after we take out the middle, we need to divide between the 2 tails. Okay? So we have our alpha. Now we want to find z alpha over 2. So z alpha over 2 is going to be the z-score the z-score, so that I have alpha over 2 area to the right of it. So this is z alpha over 2. So in our case, alpha over 2 is 0.075. So we want to find z sub 0.075, which means I want the z-score with area 0.075 to the right. Okay, so we're given the probability. We want to find the z, so that means we're going to use a q-norm function. Okay, so I'm going to my z sub 0.075, or I guess I can't do that with the decimal. I'll just write z alpha 2. Okay, so this is z sub alpha over 2. That's going to be q norm. I'm going to take I want an area of alpha divided by 2, and I want that not in the lower tail, I want it in the upper tail, right? If we look at our picture here, it's the upper tail that's shaded. So I want that area in the upper tail. So I want to find the z value with probability, and I just realized I made a mistake here. This should be a p, because I know the probability is alpha over 2. The area under the curve is alpha over 2, and in the upper tail, not the lower tail. Okay, so let's see what that is. So my z alpha over 2 is going to be 1.4395 about. So let's copy and paste that. Okay. So I now have z alpha over 2. Okay. So next I need my margin of error. My margin of error, when trying to find a confidence interval for a mean, for a population mean, my margin of error, E, is z sub alpha over 2 times the population standard deviation over the square root of the sample size. So in our case, it's z sub 0.075, which we just found, right? That is actually 1.4395 about, times our population standard deviation. We are told that we are assuming the population standard deviation is sigma equals 8. So we will have 8 divided by the square root of the sample size, and we interviewed 20 fast food workers. Okay, so to find our margin of error, that's what we're going to do. So let's stick that in the notebook. Okay, and I'm going to take full advantage of my variables here. I already have z alpha over 2 stored. I'm going to multiply that by my standard deviation. I don't have that stored, so I'm just going to look that up. That was 8. And then I'm going to divide by the square root of my sample size, which I've stored in variable. If you just want to copy and paste the numbers, that's fine too. So that would be, if you just copy and paste the numbers, z alpha over 2, we calculated right here, 1.4395 times our standard deviation of 8 divided by the square root of n, which we know from earlier is 20. So either way you do it, it's going to come out the same. So if I run that, my margin of error is 2.575. So copy that, paste it into the solution for the margin of error. Okay, now the actual confidence interval, the margin of error tells me how far I go from the sample mean to construct that confidence interval. So my actual confidence interval is going to be, the lower value is x bar minus the sample mean minus the margin of error, and then the higher value is x bar plus the margin of error. Okay, So I already have those things in my notebook. So let's just calculate them. So I already have X bar. I already have my margin of error E. So I'm just going to calculate X bar minus E, X bar plus E. Okay. So our two values are 31.67 and 36.82. So copy and paste both of those. Now, when putting them in here, order does matter. There are two boxes here. The smaller value goes into the first box. So 31.674. And then my other value, 36.825. Okay, so we are 85% confident that fast food restaurant hourly employees, on average, work between 31.67 hours and 36.83 hours per week. So let's submit it, and we have it.